Hello everyone, this is Mr. Varela, and this is now lesson 12, multiplying a decimal fraction by single digits, whole numbers, and we're going to be use estimation to confirm our placement of the decimal point. So for this one, we're going to be looking at this problem here. What do you notice is the same between all three of these products? 31 times 4, 3.1 times 4, and 31 hundredths times 4. So as you notice, they have the 3 and the 1 in this first factor, the 3 and the 1, the 3 and the 1. They also have the 4, the 4, the 4. All those things are in common between those three products. Okay, so whatever I do, I'm breaking it into two pieces, into 2, into 2. So if I was to do this, it would be 3/10 and 1 times 4. The next one would be just gonna 3/1 and 1/10. The last one, times 4. The next one would be 4. Break it up into those two pieces. 3/10 and 1/100. Notice all of them look the same. We have the same numbers for the 4 here. Sorry. 4, 4, 3/10, 1, 1, 3/1, 1/10, 3/10, 1/100. If we were multiplying using the area models, we would get 3 times 4, or 12/10, which is equal to 120, plus the area of this box would be 4 times 1, which is equal to 4 ones. So plus 4 equals 124. Next one, the area of this box would be 4 times 3 length times width. Let me just change the color. 4 times 3 would be 12. 12 what? 12 ones. And now 4 times 1 length times width. 4 times 1 is 4/10. 12 ones is 12 by itself, plus 4/10 is 0.4. Added together, 12.4. Last one, 4 times 3 would be the area of this square. Different color. 4 times 3, 12/10. 4 times 1, which is 4/100. 12/10 will be 1.2, plus 4/100, 0.04. Add them together, 1.24. Excuse me. Okay, so what do we notice between all three? The product has the same numbers. The factors have the same numbers, digits, I guess, but notice the decimal has changed. Notice the decimal reflects the product here. No decimals. The decimal is reflected here. So this is one decimal after the name of the digit next to the decimal or tenth. So this is one digit after the decimal. This one has two digits after the decimal, so therefore the answer has two digits after the decimal. So how are the products alike? Question here. They all have the same digits. How are they different? The decimal has moved based on the factors. We're going to use this fact to figure out, to estimate problems. Here's an example. Let's say we are multiplying 5.1 times 6, and the question is, which answer is most reasonable? 306, 30.6, or 3 and 6/10? Well, how about if we estimate that this is about 5, and 5 times 6 is 30. So the answer must be around 30. Not that. Yep. No. Therefore, the most reasonable answer would be that. In the homework, the students will be asked to prove this answer using letters, words, numbers, or diagrams. I decided to use this diagram where I have the area model, which I have 6. Then 5.1 would be 5 ones and 1/10. Let me just change. I can also think about it as, well, let me see. So that will be 6 times 5, which would be 30 ones, and 6 times 1 would be 6/10, which is 0.6, and 30 ones is 30. Add them together, 30.6. And that is exactly what we had. Let's practice again. What is the product? So the question is, which answer is most reasonable? 456, 4 and 56 hundredths, or 45 and 6 tenths? Let's see, let's estimate. Well, we know that 11.4 is around 11. If I multiply 11 times that 4, I get 44. Which answer is most reasonable? No. No, this is 4. Yes, 45 is closest to 44. So we're going to pick this one. Let's prove it using an area model. We switch pens. This one is broken into 3 pieces. So it's 1, 10, or 10 plus 1, 1, or just 1 plus 4 tenths, or 0.4. Notice I'm using what I already know. I just switch this number into their actual values, the standard values. Now multiplying this by 4. So we have 4 times 10 for this area, which is 40, plus area length times width, 4 times 1, which is 4, plus area is length times width. 4 times 0.4 is 1.16 tenths, or 4 times 0.4 is 16 tenths. Add them up. 40 plus 4 is 44 plus 1 is 45.6.